Okay, so this is our second part, and here's now we will how discuss the technology here and how we are actually trying to get started with it. So let's look at the traditional hydropower dam. This is how it looks like. The water flows out through gate and goes through penstock and hits the turbine horizontally, just to make sure horizontal axis. But in our situation, what we are doing is we are actually getting it down through vertical axis. So water is collected in a box here, and it goes down through this pipe. It's the turbine right over here. This is the Kaplan turbine, just to make sure. Yeah, it just rotates like that. So instead of going horizontal, we go vertical. So let me show you more pictures. Let's start with the Pelton turbine, the one that was actually shown here. As you can see, water goes through this axis, but we are getting the water go through that axis, so it'll be rotating like this, not like that, because that's the way it's rotating in the traditional hydropower dam. So this is way far different. There's less pressure, there's less applicability to it this time. And this is also another one, Kaplan turbine, which we can actually use. So the two turbines that we can use in this kind of technology that we're using is Kaplan or Pelton. And Kaplan is pretty much same of Pelton, but it's a little different in design and the way it's structured, but it's the same thing again. So as you can see, the turbines actually have a more cut, and that was more like kind of a boxed kind of turbine. So in this situation, water just hits those cuts, cutting turbine blades, and rotates the other side. Now let me go with the hydropower formula, which you might think that they will apply to our technology, but actually it won't. And let me give you a strict reason why. As you can see, the elements involved with the hydropower formula. In our technology, falling height is very, very high. And as you can see over there, the falling height, well, it's not really a falling height. This is a different kind of falling height, right? And even in the Pelton one, this is a different kind of falling height. So ours is more kind of a dense kind of falling height, so it involves more pressure. It has a pipe, so that really increases a lot of pressure. We can reduce the pipe through which the water is flowing out down to hit the turbine. So we will not consider this formula because of these two things, the density and the falling height. So as you can see, no pipe pressure element. So next video we will talk about the formula. This video is getting a little bigger, so